Welcome to the second lecture of Metrology and Quality Control. In this lecture, I will introduce briefly the meaning of measurement standards. In the previous lecture, I gave an introduction to Metrology and Quality Control, and this is the brief summary of the previous lecture. Every quantity that we want to measure, there must be a unit, and this unit should not be followed only by the person who is taking the measurement. It should be followed universally. The correctness of the measurement is important. So only taking measurement is not sufficient, but we as a scientist or engineer should also bother about the correctness of the measurement. Only the measurement is not sufficient. The validation of the result should also be done. That means if you are reporting the length of an object, then you have to also report the accuracy involved in the measurement of that length. The progress in metrology decides the progress in other fields because the sophisticated or the sophistication in the measuring instruments will decide how accurately or precisely a quantity can be measured, and the measurement of any physical quantity affects the result of an experiment. And as the experiments are performed in almost every field, that's why the progress in any field is dependent upon the progress in metrology. Metrology is mainly concerned with establishing units of measurement, developing methods of measurement. So for example, if you have to measure length, then how many possible methods are there to measure the length, and how many of them gives a precise value of length. Then analyzing the accuracy of methods of measurement. Before understanding the measuring standards, let us first understand a physical measurement. I am sure that you must have done many measurements in your life up to now, either in labs or in your day-to-day routine. An act of deriving quantitative information about a physical object or action by comparison with a reference. So this is the definition of measurement, that it is an act of deriving quantitative information about a physical object, for example length or volume, mass, density. So whenever we are measuring a quantity, a physical quantity, we assign a numerical value to that quantity. So that we are actually deriving a quantitative information about that physical object or action by comparison with a reference. So generally, whenever we do a measurement, we are comparing with a reference like a steel scale or a pressure gauge, for example. And hence, a physical measurement consists of three important elements: a measurand or the quantity to be measured, comparison or comparator, reference or the measuring instrument. Okay, so I will explain the comparator later on. So measurement is the quantity to be measured, reference is the measuring instrument generally. So let's take an example to understand these three elements in any physical measurement. So suppose we want to measure the length of a surface table. So this is a surface table and we want to measure this length of the surface table. Okay, now as we want to measure this length, so this length of the surface table becomes the measurand, and we are comparing the length, the unknown length of the surface table with respect to a reference, or with a reference which is the scale in this case. So we are using a scale to measure the length of the surface table. The length of the surface table becomes measurand, and as we are comparing the known length of the surface table with the reading, with the values on the scale becomes the reference, and then we compare this using our eye. So we compare this using our eye. So our eye becomes the comparator. Okay. So I hope you have understood the three elements in a measurement. Direct and indirect measurement. Some measurements are taken directly, just like this example of measuring length of a surface table. In this case, we are directly measuring the length of the surface table. However, in some cases, uh, or in some measurements, the quantity to be measured is not uh, measured directly. For example, measurement of temperature using thermocouple. In case of thermocouple, the temperature is first expressed as the change in voltage, and then this change in voltage corresponding to the temperature of the object is then interpreted as the measurement of the temperature of the object. So there are several examples of indirect measurements. At some point of time in history, we realize that the measurement standards are necessary for the globalization of the products. The simplest question that will explain explain the meaning of measurement standard is how much length is 1 meter, how much length is 1 feet, how much mass is 1 kg, how much mass is 1 gram, how much time is 1 second, how much time is 1 minute. And this standard has to be followed everywhere in every country. So a meter of length is in India is the same 1 meter length in US, is the same 1 meter length in France, or is the same 1 meter length in any other country or any other place across the globe. Same thing about mass and time. 1 kg of mass in our country is 1 kg of mass in any other country. And this goes for any physical quantity that exists on this planet. As far as our syllabus is concerned, we are going to talk only about length. So we will be talking about measurement standards of length only. Length can be measured by using a line standard, and an example of line standard is a steel scale or a ruler or any scale or any measuring instrument that has line inscribed on its surface. So you can see that these are the lines. There are lines inscribed on the surface of this ruler, and we measure the length as the length between the lines inscribed on the surface of this measuring instrument. Then we are referring to a line standard. So when we say line standard, we mean that the length is regarded as the distance between the lines inscribed on the surface of a measuring instrument. A steel scale, a vernier caliper are examples of line standard. Another way of measuring length is end standard. So what is end standard? So if you have a cube or if you have a rectangular block just like shown in this figure, then what I can do is if I want to measure this distance L, let's say this is unknown distance, then according to n standard, this distance is measured as the distance between those two parallel surfaces. So one here in the front and one on the back side. So this is another parallel surface, and those two parallel faces or planes are simply the surfaces of the rectangular block. So the distance between the end surfaces of this rectangular block is the required length. Okay. Similarly, the other possible way is if you want to measure the distance d, then that would be the distance between this surface of this block and the one behind. Okay. So end standard means the distance between the end surfaces of rectangular block which are parallel. That would be an inch standard. An example of inch standard is a slip gauge. So these are all the slip gauges. Okay. And the distance between the parallel surfaces that are used for any particular slip gauge is inscribed on one of the surfaces. So here is an example. So 20 on that, 50 on that. So this means that this particular slip gauge can be used to measure a distance of 20 mm. Okay. Similarly, this slip gauge can be used to measure a distance of exactly 50 mm. That means if you want to measure 70 mm of distance, you need to combine those two slip gauges. So we will talk about combining slip gauges later. Actually, the correct term is ringing. So we will discuss ringing when we talk about slip gauges. But hopefully you have understood the meaning of measurement standard to establish the unit of for a physical quantity. Okay, so in our syllabus we are going to discuss the measurement standards of length. In the next video we will begin with line standard. Thank you.